Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there, though all children are welcome to tune in. This is the 11th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools in Rutherford County. And I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back to previous lessons to view them because we may be talking about things previously learned today. So today we'll be learning about generating equivalent ratios. What you'll need today to fully participate in this lesson is paper and pencil and a calculator if you have one. Y'all ready? Let's begin. So here's a question I want to throw at you. Have you ever mixed two colors of paint to make a new color? Again, sixth graders, think. Have you ever mixed two colors of paint to make a new color? All right, so today we're going to start out with a problem that has Sally trying to make a new paint color by mixing two colors of paints together. Y'all ready? Let's read it together. Here's our problem.
All right, so here's our problem. Our problem says Sally has 3 pints of yellow paint and 4 pints of red paint. She used all of the paint to make a certain tint of orange paint. How many pints of red paint should she mix with the 24 pints of yellow paint to make the same tint of orange? Solve this problem any way you choose. So I'm going to draw our paint cans. Our top pints will represent 1 pint of yellow. Our bottom ones will represent 1 pint of red. So I'll give you a moment. I want you to write down any thoughts you have to help Sally. Let's look for relationships. How can we use the relationship between the number of pints of yellow paint and the number of pints of red paint to answer the question? Let's look at 2 possible solutions. Dante and Eva have solved this problem in 2 different ways. So let's look at Dante's method. Dante used a bar graph to find the solution. He knew that the same ratio of yellow to red had to be maintained. If there is more or less red included with the yellow paint, it would be a different shade of orange. So he said that he needs 32 pints of red. What did Dante do? He knew the ratio of yellow paint to red paint was 3 to 4. I'm gonna write that down. Since we were told that Sally now has 24 pints of yellow paint, he divided 24 into 3 parts. Since 24 divided by 3 equals 8, he put 8 in each part of the diagram. This shows that each of the 3 parts now contain 8 pints. Because each of the parts of the diagram now contains 8 pints, he did the same for the red paint. To maintain the ratio of 3 to 4, he now has 3 times 8 and 4 times 8, or 24 to 32. Dante is correct. He will need 32 pints of red paint. Now let's look at Eva's method and let's see what she did. So Eva did the following. What do you notice and what do you wonder about their solution paths? I noticed using a model helped Dante. Using division and multiplication helped Eva. So Dante used a model where Eva used division and multiplication. We will see how those can work together as we determine strategies we can use to generate equivalent ratios and solve like problems like Sally's. I'm looking forward to working alongside of you today. Y'all ready? Let's dive into some more. So now my question is, how can we find equivalent ratios? Let's try a few examples to see. So I'm going to draw a bar graph. So you got your word problem and we got your visual. Let me see if I can get them side by side somehow. Yes, you're right. It's the number of basketball players and the number of soccer players. One way to solve this problem is to make a table with equivalent ratios. Remember, equivalent ratios are ratios that express the same relationship. Let's make a table using all the information that we know. So here's our table. So we're going to multiply both terms of the original ratio by the same number to find an equivalent ratio. So we're going to start by multiplying the first term by 2. So when I multiply 16 by 2, that's going to give me 32. And 48 by 2, that's going to give me 96. All right, so let's keep going to create this equivalent table. So now I'm going to multiply my next set of numbers by 3. So now I have 48 and 144. You are right. So now let's multiply our next set of numbers by what you guys think. Good, let's do it by 4. What do you get here? Because remember, we are trying to get 64 basketball players, and we're not there yet. Correct. You get 64 and 192. Do we have 64 basketball players now? Good. So what is this table telling us? Yes, when we have 64 basketball players, we have 192 soccer players. Now, does that answer our question? Yes, it does, because the original question was, how many soccer players are there if we have 64 basketball players? So another way we can do this same problem is to use multiplication. We can multiply both terms by the same non-zero number. We started out with 16 to 48. So I'm going to write that down. We started off with what do you think we can multiply both terms by? Remember, we need to have 64 basketball players, and I know that this 16 represents my basketball players, while this 48 represents my soccer players, and we have to have 64 basketball players. So what can we multiply by? I agree. We can multiply 16 by 4 to give me my 64 basketball players. So we will multiply both terms by 4. Do you remember that from our previous lessons with equivalent fractions? And that's going to give me 192. So now I know that I have 64 basketball players and 192 soccer players. Good job. Let's try another one. And we're going to use multiplication with this one. So I want you to complete the table using multiplication to find ratios that are equivalent to 4 to 5. So here's our problem. All right, so let's dive in it. If we use what we did in the previous problem, we can multiply both terms by the same numbers to generate equivalent ratios. What would you like to multiply first? Okay, we'll start with 2 again. What are our new terms? So I'm going to multiply times 2 times 2. So what would be our new terms? You're correct. It is 8 and 10. What is another number you would like to multiply by? Okay, we can do 4. So if I multiply, turn by 4. What do we have now for our new terms? I agree. We now have 16 and 20. Let's try one more set of terms. We can multiply both of these by 5 this time to continue to create our equivalent ratios. Times 5 times 5. So now what would our new terms be? You got it, 20 and 25. How is finding equivalent ratios similar to finding equivalent fractions? Remember that from our previous lesson, so I want to know, how are they similar? Good. When you find equivalent fractions, you multiply or divide the numerator and denominator by the same value. When you find equivalent ratios, we can do the same thing. Let's see what this looks like with division. Let's use division to find equivalent ratios in a couple of problems. So here's our new problem that we're going to use. Put that there, and I'm going to write our problem down. All right, so here's our problem. Let me put that there. Put that there. So it says Sarah made baskets on some of her shots in a basketball game. If she continues to make baskets at the same rate, how many baskets will Sarah make in her next 6 shots? So here's what Sarah did. These are the shots she made in the baskets. Let's start by looking at a table to find equivalent ratios. So I'm going to move this up so we can look at a table to find equivalent ratios. How can we use the table to find how many baskets she will need in her next 6 shots? We will need to divide 18 and 12 by the same number. Let's start by dividing by 2. What are our new terms? So same thing, but now I'm going to divide by 2. What are our new terms? I'm going to divide 18 by 2. That's going to give me 9. And 12 by 2, that's going to give me 6. But we are looking for 6 shots, so what can we divide the 18 by to get 6? 3, correct. So I'm going to divide both terms by 3. 18 divided by 3 is going to give me what? Correct, 6 shots. 12 divided by 3 is going to give me 4 baskets made. So our answers, or our new terms, is 6 and 4. Good job. So we can also use division to find this answer. So if we start off with, let me get to my whiteboard. (18 to 12), by what number do we need to divide 18 by to get 6? Correct, we can divide each term by 3. That's going to give me, again, that ratio of 6 to 4. So this tells us that Sarah will make 4 baskets in her next 6 shots. Good job, Sarah. So let's try this one together. Complete the table using division to find the ratios that are equivalent to 40 to 28. So let me put up my table. Again, I want you to complete this table using division to find the ratios that are equivalent to 40 to 28. All right, so let's check your answer. Remember, we may have different answers. One possible answer is this table showing first dividing both terms by 2 and then dividing both terms by 4. So let's show this. So when I do that, that's going to give me 20 to 14. So now I'm going to divide both terms by 4. And that's going to give me 10 to 7. So I see that you got a few different answers. Yes, 5 was a good number to divide by also. I also see that somebody divided by 10, which is great. So it doesn't matter, just as long as we're dividing our top term and our bottom term by the same numbers. So this is great, y'all. This reminds us that there are an infinite number of equivalent ratios, just like we had when we worked with in earlier grades with equivalent fractions. You guys are doing great with this. Let's keep going. So there may be times where we are given ratios and asked to determine if other ratios are equivalent. We may multiply or divide to determine if they are equivalent. Let's practice. All right, so here's our problem. This problem says pi is the ratio of the circumference of a circle to its diameter. This ratio is approximately 66 to 21. Which of the following ratios are equivalent to 66 to 21? 22 to 7, 33 to 10, 44 to 14, or 88 to 28? I'm going to give you a second to solve this. So I know in this problem, we can use both multiplication and division to determine if the ratios are equivalent to 66 to 21. So let's start with the first given ratio, 22 to 7. Do you think we should multiply or divide 66 to 21 to find out if 22 to 7 is equivalent? I agree. Since it is smaller than 66 to 21, we will divide. So I'm going to do 66 to 21, and I'm divide them both by 3. When I do that, 66 divided by 3 is going to give me 22. 21 divided by 3 is going to give me 7. So yes, 22 to 7 is equivalent. Great job. Let's look at the next one. 33 to 10. Are we going to multiply or divide? You're right. We can divide that each one, since it's smaller, to figure out if it's equivalent or not. So I'm going to do the same thing. 66 to 21. And I'm going to try divided by 2. 66 divided by 2 is going to give me 33. 21 divided by 2 is going to give me 10 and a half. So is that equivalent to 33 to 10? It's close, but you're right, it is not. So 33 to 10 is not equivalent to 66 to 21. I want you to try the other two yourself, and we will check them. Remember, since we discovered that 22 to 7 is equivalent, we can use that to help us. All right, so since I know that 22 to 7 is equivalent, I can use that to help me. So I'm going to multiply 22 to 7 both by 2 to see if 44 to 14 is one of my equivalent ratios. 22 times 2 is going to give me 44. 7 times 2 is going to give me 14. Is that equivalent? Correct. So I know that 44 to 14 is equivalent to 66 to 21. Good job. And now let me try the last one. 88 to 28. And I can use multiplication again. I'm going to multiply both of those by 4. So I'm going to do 22 to 7, I'm sorry. Multiply both by 4. 22 times 4 is going to give me 88. 4 times 7 is going to give me 28. So 88 to 28 is also equivalent. So our equivalent ratios to 66 to 21 is 22 to 7, 44 to 14, and 88 to 28. Good job. So here's another one for you to try. I want to know if 4 to 7, 6 to 10, and 24 to 42 is equivalent ratios to 12 to 21. I'll wait for you to solve this so we can check our answers. All right, let's check. Did you get... Oh, that's not working. Let's try another one. 4 to 7 and 24 to 42 as equivalent? You are correct. Good job. So when you use division for this, we can see that if I divide it, and I can divide by 3, I can see that 4 to 7 is an equivalent. And if I use multiplication, I can multiply both of these by 2 to see that 24 to 42 is equivalent. So as we pull our learning for the day together, we can see common threads of understanding. We see that we can find equivalent ratios by multiplying or dividing both terms of a ratio by the same non-zero number. So for example, multiplying both terms by a non-zero number. So if I had 30 to 40. I can multiply both my top term and my bottom term by 2 to give me 60 to 80 for my ratio. As well as if I did 30 to 40, I can divide both terms by 10 to get our equivalent ratio. We will work together on a few to make sure you are able to work on your own. So let's read through this next problem. This says Shiloh is sharing jelly beans. The jar of jelly beans has the ratio shown. If Shiloh keeps the ratio the same and gives her friend 7 pink jelly beans, how many green jelly beans should he also share? So take a minute to think about it and how you're going to set this up. So you're right. We can use multiplication or division to find our ratios. You can work these problems if you want. Let's do this and then we'll discuss. All right, so let's check how you did. Let's start off with dividing. I'm gonna use division. Dividing our first term by 2. That's gonna give me 16 to 28. Now we can divide by 4 to get 8 and 14, or we can halve our next term. Then we keep going. I can either divide some more, or I can halve this term to get half of 14 is 7, half of 8 is 4. So now I know that Shiloh will have to share also 4 green jelly beans when he's giving out 7 pink jelly beans. Using what we've done today, I'd like you to take a moment to write 3 equivalent ratios for this term here. 12, 16. Make sure you use both multiplication and division, and remember there are many possible answers. You just find 3 and we will compare. All right, so let's compare. Remember, we are working with ratios 12 to 16. I can even write it that way. So here are some possible answers if you divide it. So a possible answer was 3 to 4, and another possible answer is 6 to 8 if I use division. If I use multiplication, some possible answers is 24 to 32 and 36 to 48. I think y'all got this.
Great work. Today we reviewed ways to generate equivalent ratios. I hope you're seeing some connections to equivalent fractions from previous lessons. You sure did do a great job. After the video, you will have some practice problems to practice on your own. I will show the independent practice problems to you now, or you can find them on the Tennessee's Department of Education website at www.tn.gov/education. Good luck and thanks for hanging with me today. Boys and girls, I have enjoyed reviewing generating equivalent ratios with you. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.